All right, y'all. So 8.5 is going to cover rational functions. And y'all, when we talk about rational functions, we're talking fractional. Okay. So the first few examples are something that we've already done in the past, and that is finding a domain. Now, the difference in this section versus the early sections when we found a domain is we're going to write these domains in interval notation. Okay. All right, y'all. So this first two problems, we're going to determine the domain. All righty. So my first one, I got f of x equals x squared over 8 minus x. All right, y'all. So we've been doing this type of problem earlier in the course. So we're finding the domain. So remember, when we find a domain on a fraction was one of the things we were worried about. And we knew that the bottom of a fraction cannot equal zero. So we came in and actually set that bottom equal to zero and solved this for the variable. Once we get our answer, we're going to exclude it from our domain, okay? So y'all, to solve this, you can do it either two ways. You can either subtract the 8 from both sides or add x to both sides. So most of y'all like your x's on the left side. So I'll move this 8 to the other side by subtracting 8. Are y'all doing that? Those cancel. And I get a negative x on the left side equal to a negative 8. All right, so one more step. We don't want this x to be negative, so we divide it by the number in front of it, which is technically a negative 1. So we'll divide both sides by negative 1. So negative x divided by negative 1 makes that a positive x. And then over here, negative 8 divided by negative 1 makes that a positive 8. So we need to exclude 8 from our domain. So remember, interval notation starts at negative infinity. And then, since we're kicking this 8 out of our domain, we're going to union around that 8. And then from 8, we can head off towards positive infinity. So unioning around a number is how we were kicking them out, okay? All right, y'all letting one in real quick. All right, so another one doing the same thing. So y'all, this one they're giving me f of x equals 2 over x squared plus 3x minus 28. All right, y'all, so the same type problem as this one, except now I've got an x squared in here. So this exponent 2 means I will find two numbers to exclude from my domain. Okay? So we're going to set that equal to 0. And y'all, since this is a trinomial and it's quadratic, since I got an x squared in it, you could solve it by quadratic formula or factoring. So I'm going to factor it, but you could get your two answers using the quadratic formula, okay? No, I like factoring. I'm getting y'all better at factoring. So in the front of each parentheses, x squared would be an x and an x. All right, now I'm focusing it on the last number. This last number is negative. So since the last number is negative, your two factors will have unlike signs. Okay? Now, I'm going to find factors of 28 that subtract to give me 3. So do y'all got any factors of 28? So two numbers that multiply to equal 28, but when we subtract them numbers, we get 3. All right, y'all, so let's think about this. What factors of 28 give me 3? And Darren, that would be 7 and 4. So my numbers are 7 and 4. Remember, the larger number has the same sign as the middle. So y'all, your 7 will be positive, and your 4 will be the negative. All right, y'all. Now that we got it factored, we set each of these factors equal to 0. And then solve these both for the x's. And y'all remember, factor form is always opposite in sign than the actual solutions. So that was negative. So when I solve this, it's going to make this one positive. And I get a x is a positive 4. All right, so I got two numbers I'm going to kick out of the domain. So we're starting at negative infinity on this. And we're going left to right. So the first number I would hit from negative infinity would be negative 7. So we need to kick this negative 7 out by unioning around that negative 7. All right, so we did a union around negative 7. We kicked it out. Now, from negative 7, we're going until we hit 4. And we got a union around that 4 to kick it out of the domain. But y'all, that was the second number that I had to kick out. So no more numbers are getting kicked out. So from 4, our domain heads towards positive infinity. So if you're kicking out one number, you got one union. You're kicking out two numbers, you got two unions on them, okay? All right, so y'all, this was just basically what we did earlier in the class, except now we're using this interval notation, okay? All right, y'all, so before we get into any more problems, I'm going to give you a few definitions. So the first definition is a vertical asymptote. Okay, y'all, I'm going to earlier in life, we had them 7 basic graphs. And we had one where y equaled 1 over x. So, y'all, that graph came down, sort of curved, and went down that way on the left side. It sort of curved down like that. So, this was one of our 7 basic graphs, the 1 over x. But, y'all, I want to use this to sort of explain what these are. So, first of all, vertical asymptote. It's an imaginary line that the graph cannot cross over. All right. It occurs where the function is undefined. Okay. And these vertical asymptotes come in the form of an equation. And that equation would be x equals some number. All right, y'all. So I'm going to show y'all. If you put a 0 in for this x, that would make this undefined. So, and x's 0 is right on that y-axis. So this would be like my imaginary vertical line that the graph cannot cross. So that's why this graph is just going to keep going up towards infinity, but it will never cross over that graph. And then this side, the graph is going to head towards negative infinity, but it will never cross over this imaginary line. Y'all, it can't because the graph is undefined if you put a 0 into it, okay? So that's what a vertical asymptote is. It's a vertical line, and my graph cannot cross over it. All right, y'all, next is a horizontal asymptote. All right, y'all, well, guess what? This is an imaginary horizontal line. That the graph tries to approach so as my x's go further and further out, the graph tries to approach this imaginary horizontal line. Now, these come in the form of y equals some number. So these horizontal asymptotes would be like a little line that extends out from your graph. And this graph just tries to approach that line. It never equals that line. It just gets closer and closer and closer as these graphs head out towards negative and positive infinity. Now, there are three cases to determine the horizontal asymptote. Now, what we do to determine these horizontal asymptotes, we're going to look at the degree of the numerator and the degree of the denominator. Now remember, the degree is the highest exponent for the numerator, and then we'll look at the degree, which is the highest exponent of the denominator. So there's three cases. If the top degree is greater than the bottom degree, so if the top has a bigger exponent than the bottom, then there would be no horizontal asymptote. Y'all, because your graph is just going to shoot towards infinity and it will have no asymptote that it's trying to reach. That happens when the top exponent is higher than the bottom exponent. Now, if the bottom degree is greater than the top degree, so if you got bigger exponents in the bottom than you do on the top, then your horizontal asymptote would be y equals 0. Just like this graph, they're trying to approach this x-axis, and the x-axis is where the y value is 0, okay? So that would give me a horizontal asymptote y equals 0. So top bigger, no asymptote. Bottom bigger, y equals 0. And y'all, there's only one more case. What if they're equal? If the top degree equals the bottom degree, so the largest exponent up top matches the largest exponent on bottom. If you have that case, then your asymptote will be y equals a over b, where a and b are the lead coefficients. So y'all, the lead coefficients are the numbers in front of those variables that have the highest exponents, okay? So if you have say, an x cubed on top and say 5x cubed on the bottom, in this case, my horizontal asymptote would be something like y equals. And y'all, you just got to remember, if the variable don't have a number in front of it, that's like a 1. So this would approach 1 over 5. And that would be my horizontal asymptotes as it went out towards infinity, okay? So this is what I'm talking about when I talk about lead coefficients, okay? All right, now, so next I'm going to show you how to plot a graph using all this information. That way you'll be able to choose which picture you need to, because they'll give you 4 pictures and you got to choose the one that matches your graph, okay? Now, you can always do these on y equals on your calculator to get the picture, but I just sort of wanted to show y'all how to do them by hand, because they're sort of neat when you do them by hand. So y'all, let me get this paper where it ain't folding. All right, so on this example, they want me to list all the asymptotes. So we're going to list the asymptotes. Then we're going to graph the function. All righty, so we got to figure out how do we graph these functions. So the steps to graphing. We go to the first step. I'm going to plot the vertical asymptote. So I'm going to draw the vertical asymptote. Now remember, this is a vertical line that my graph cannot cross. Next, I'll figure out the horizontal asymptote. Well, that's just going to be another imaginary line, and I'll sort of draw it toward the end of my graphs because that's what the graph is going to try to approach as it goes towards these infinities. All right, at that point, I'm going to find any x-intercepts. Because y'all, if I find the x-intercepts, that'll tell me where my graph is crossing over the x-axis at. And to find the x-intercepts, I set the numerator equal to 0. and solve it, okay? So that'll give me either 1, 2, or none. Sometimes if you don't have a variable in the numerator, then that means you don't have a x-intercept and it's not crossing over the x-axis. All right, y'all, next I'll find the y-intercept. And the y-intercept is where it crosses over the y-axis. And to find that, I'm going to find f of 0. So I'll put zeros in for the x's in my function and see what I get. That'll tell me where it's going to cross the y-axis at. And then y'all, if needed, find other points. So that would be put a 1 in for the x's or a 2 or any other points you need if you need them, okay? So for this one, the function they're giving me is r of x equals 10 over x squared minus 81. Y'all, so first I'm going to show you how to find a vertical asymptote. Remember, a while ago I told you that a vertical asymptote occurs where the graph is undefined. So you find a vertical asymptote the same way you found your domain. Because I'm looking at places that make this bottom 0. So to find a vertical asymptote, I'm going to take the denominator and set it equal to 0. All right, y'all, two ways to solve this. But since I got a number and an x squared, and I don't have the x term, I'm going to solve this real quick by doing the square root. So I'm going to add 81 to both sides. So that'll give me x squared. That cancels on the left side. And that'll equal 81. And then I'm going to take a square root of both sides. Now remember, since I'm taking the square root of a number, I'm going to use my plus or minus. Since that's an x squared, that 2 is telling me I got to get two answers, okay? So then I get x equals a plus or minus square root of 81, which is 9. So that means my asymptotes that are vertical will be at x equals positive 9 and x equals a negative 9. Okay, so y'all, let's sort of get me a graph going here. So I'll go out about 10 on this one since they got vertical asymptotes at 9. And then negative, and then go left. Okay, so at the moment, I know I got a vertical asymptote at negative 9 over here. And my graph cannot cross over this line. And then over here at positive 9, I got another vertical asymptote. So my graph cannot cross over either one of these vertical lines. All righty, y'all. So now I'm going to find my horizontal asymptote. Well, my horizontal asymptote, I'm looking at the degree of the numerator and the degree of the bottom. Well, y'all, you don't even have an x up here at all, the variable. So that means the highest degree is in the denominator. That's a degree 2. Up on top, you got a degree 0 because there's no variable. So the denominator degree is higher than the top. So the degree on bottom is greater than the degree on top. And we said when the bottom degree was greater than the top, my asymptote would be y equals 0. So that means as this graph heads towards negative infinity and positive infinity, it's going to try to get to this imaginary horizontal line. All right, y'all. So next, I would try to find my x-intercepts. To find my x-intercept, I would set the numerator equal to 0. Well, that's just 10. Well, y'all, that don't even have a variable. So this is a false statement. Since that is a false statement, that means that there are no x-intercepts. The only way you would get x-intercepts is if you got the variable in that numerator and you solved it for x and got some answers out of that, okay? But since there's no variable in the numerator, we have no x-intercepts, so this graph does not cross over the x-axis. So y'all, let's see if we got a y-intercept. The y-intercept, I said find f of 0. All right, so f is 0. I would put a 0 in for that x. So I got 10 over 0 squared minus 81. Y'all, that's just going to give me a 10 on top over a negative 81 on the bottom. So this is negative 10 over 81. And y'all, if you punched it into the calculator, you'd get a very, very, very small number. But all I'm worried about is that that number is negative. So somewhere in between 0 and negative 1, this graph is crossing over the y-axis. All right, y'all, so check this out. On the left side, this graph does not cross the x-axis, so that means this side has to come down and head towards negative infinity, but it will not cross that. Okay, my graph crosses at this negative 10 over 81. And remember, it does not cross the x-axis here, so this side has to come and head downhill. It cannot cross that axis, this vertical asymptote. So y'all, the left side is going to come in, and it's going to curve, and it's going to try to get down to this horizontal asymptote, but it never does touch it. And y'all, the same thing on this one. It's going to come down and head towards that horizontal asymptote right there. So this one would give you 4 pictures. And y'all, the one that we matched up would be D on this one. Now, if it would have been a positive y-intercept, then it would have looked like this C, and the other ends would have came down. But since it was negative, it had to be this one because it does not cross the x-axis. And y'all, let me show you on your calculator real quick. So on the calculator, I would go to y equals. I would make mine look like a fraction by hitting alpha y equals and enter. Whoops, I think I hit something bad. All right, so alpha y equals enter. Oh, I know what it is. Let me fix my mode. All right, now it's got my uh fraction looking correct. So I had a 10 on top. On bottom, I had a x squared minus 81. So x squared minus 81. See, all that looks like it. So I'm going to hit graph and show you what this looks like. And y'all, there it is. It's the graph that I showed you with the bottom part crossing right over. You can't really tell, but that is barely under the x-axis there. And then both ends are shooting down when it reaches these little vertical asymptotes, okay? Now, if you were to zoom it out, you would see that in the long run, it's trying to get to that x-axis, okay? But y'all, they're just going to give you the four pictures to look at. So you choose the one that matches your graph, and then you move on. Now, let me show you something. Right here, it says the oblique asymptote. You're always going to check B for that answer. Oops, not this one. For the oblique, you're going to check B for oblique because we're not doing oblique asymptotes, okay? So always choose B. There is no oblique when you get to that question asking for that. We will find vertical asymptotes. And remember, you got to put them in as an x. So we had x equals -9, x equals 9. It's got to be in the form of an equation. And then the horizontal asymptote would be y equaled 0 on that. And it's got to be an equation. Okay? All right, y'all. So the next few examples are just we'll do a few examples finding horizontal asymptotes, and then we'll do a few examples finding horizontal asymptotes. And then at the very end, we'll look at doing some more graphs. So y'all let me get this up here right. All righty. So for the next few examples, and these will be like from 4 to 7. So from 4 to 7, you're going to find the vertical asymptotes. All righty. So for this first one, I got f of x equals 1 over x minus 1 squared. All right, so the thing we're going to change up is this bottom and make you use different methods to solve this, okay? So this first one, I'm going to take that denominator, set it equal to 0. So basically, finding the vertical asymptotes is the same as finding that domain, okay? You know, x minus 1 squared means x minus 1 times x minus 1. All right, so I got the same factor, so I've only got to do this once. I'm just going to set x minus 1 equal to 0. Solve that for the x by adding 1. And I get x equals 1. This is a repeat, so it would give me the same answer. So the vertical asymptote only has to be listed one time when you got a repeat. And y'all, what I would put in MATLAB is that answer right there, x equals 1. All right, for my next one, I got f of x equals x minus 3 over x squared plus 4x. All right, so we haven't seen an equation like this in a while in which it has the x squared term, the x term, but it does not have a number at the end. So I solved these a little bit different than the ones where I had the numbers at the end, okay? I'm going to set this equal to 0. And when you got an x squared term and the x term, the way you solve those is by factoring out the greatest common factor. So both of these have at least one x in it. So we're going to factor out an x. So on this one, I'm going to factor out the greatest common factor. So if I take an x away from both of these, x squared divided by x leaves you an x plus 4x divided by x. Their x's cancel and leaves you a 4. So this was factoring out the greatest common factor. All right, now that I got it factored, I'm going to set both of these equal to 0. So y'all, when your greatest common factor is a variable, 0 is always going to be one of them answers, remember. And then on this one, you would solve it by subtracting 4. And this would give you x equals negative 4. So in MATLAB, x equals 0, comma, x equals negative 4. Remember, it wants them in the form of an equation. If you put 0, negative 4, it's going to mark it wrong. You got to have those x's. All right, y'all, the third one, f of x equals x minus 2 over 4 minus x. So, I'm going to set 4 minus x equal to 0. Now, y'all won't go when I had 8 minus x. I did it by moving the number over, and then I had to divide by negative 1. But y'all, let me show you the quickest way to do this. I got a number over here. This variable is negative on this side. I'm just going to add an x on this one and show you the quickest way to do this would be to get a 4 over here. Those cancel, and 4 equals x. But y'all, guess what? 4 equals x is the same thing as x equals 4. Okay? So my answer in MATLAB, x equals 4. So I know y'all like them x's on the left side, but this problem was easier to do in one step by just adding the x. If you'd have subtracted 4, you would have had a negative x equal negative 4. And then you would have had another step of dividing by that negative 1 to finally get an x equals 4. So either way works, okay? You can do it in 2 steps or 1. All right, so 4, 5, 6. So the last one of those has, let's see. Okay, not the last one. I got 2 more. So this one has 2 over x plus 5, x minus 3. All right, so take this bottom, set it equal to 0. So we're happy this one's already factored. So I'm going to set each of these factors equal to 0 and solve. Hey, you also solve these. I'll subtract 5 on the first one. I get x equals a -5. And then on this one, we would add 3 and get x equals a +3. So these would be vertical asymptotes, 2 of them that the graph couldn't cross over. So y'all in MATLAB, I would put x equals -5, comma, x equals a +3. Okay, so, all right, so this one was a repeating factor. I only had to kick out one number. This one I solved by factoring out an x and then setting both them equal to 0. This one we just solved for x either way you want to, and we got one number 4. All right, so this one was already sort of factored. This next one we're going to have to factor. They got f of x equals x squared plus 3x minus 10. We're going to divide that by x squared minus 4x minus 12. All righty, y'all. So here we go. We're going to set that bottom equal to 0. So you could use the quadratic formula. I'm going to solve this by factoring. So once I get it factored, it'll look something like this. All right, y'all. X squared is an x and an x. This last number's negative again. So remember, last number's negative. I got a positive and a negative. Now, the larger factor that I find will be negative, and then the smaller factor will be positive. So, y'all, this is on y'all again. I need me some factors of 12 that'll subtract and give me 4 this time. So, what two numbers multiply to get a 12? But when you subtract them two numbers, you get me a 4. So, Darren, what you got? 2 and 6? Good job. All right, remember the 6 is larger, so it'll be negative like the middle number. And then my 2 will be my positive. All right, y'all, so I'm at this point. Set both these equal to 0 and get them asymptotes. So, y'all, this first one, we're going to subtract 2 from both sides. We get x is a -2. Second one, we'll add 6 and get x is a +6. So in MATLAB, we would put x equals -2, comma, x equals a +6. And also, that's the gist of those. Vertical asymptotes. Set that bottom equal to 0 because we found those the same way we find our domain, okay? All right, y'all, next I got, let's see, 1, 2, 3 of them doing a horizontal asymptote next. So for these examples, we're going to find the horizontal asymptote. Or they say determine the horizontal asymptote. But y'all remember, all I'm going to be looking at is the exponents. The highest exponent on top and the highest exponent on bottom. I'll have 3 cases. Top's greater, bottom's greater, or they're equal, okay? So these problems are going to be 9 through 11. Okay, so 9 through 11, you're going to be finding horizontal asymptotes. So y'all, my first one, f of x equals 2x squared plus 5 over 5x squared minus 3. All right, y'all, so I'm just looking at these exponents. Well, the highest exponent on top is equal to the highest exponent on bottom. So that means the degree of the top equals the degree of the bottom. So that's when I said your horizontal asymptote would equal A over B. Well, remember, A over B is these lead coefficients. So when they're equal, you look at the number in front, and I get a 2 over 5. So as these x's head towards those infinities, it's going to try to approach whatever 2/5 equals, okay? So, y'all, that's what MathLab wants on that one. So that's what I meant by the A over B, remember, okay? All right, y'all, let's see what this next one. I think they're going to give us one of each case. So this one, f of x equals x squared minus 7 over 7x to the fourth plus 5. So y'all, I'm going to give y'all a chance on this one. Figure out where your degree is higher at, and then look at them 3 cases I gave you to figure out what this horizontal asymptote would be. So y'all, here's your exponents you're looking at. So this one's a little bottom heavy, right? Sort of like J-Lo, bottom heavy. So the bottom degree is greater than the top degree. So y'all, guess what? When you got a bigger exponent in the bottom than you did on the top, your horizontal asymptote is going to be y equals 0. So these aren't bad. Like I said, you're just looking at exponents on these, okay? All right, so the next one was f of x equals x to the third minus 2x squared plus a x minus a 3 over x squared minus 10. All right, y'all. So, once again, I'm looking at exponents. On this one, the higher exponent is in the top. So your degree on top is greater than the degree on the bottom. So when that happens, and you got a higher exponent than you on the top than you do the bottom, this was the case in which we had no horizontal asymptote. Okay, these graphs won't try to get to anything. They'll just shoot up towards infinity. So usually they got a choice B on this one. And you would just choose B, no horizontal asymptote. All right, y'all. So we got 2 graphs to do, and then we'll be done with these, okay? So let me get us ready for some graphs. All right, so for these examples, and y'all, the last one, I'm even going to show you what a hole is, okay? What makes a hole in a graph? So that last one, I'll show you that. So for these graphs, we're going to find the domain. We're going to find the domain and do the interval notation. Any asymptotes. So we're going to find our vertical and horizontal asymptotes, the x and y intercepts. Well, y'all showed you how to do those on that graph earlier. Set the numerator equals 0 for the x-intercept, find f is 0 for the y-intercept, and then they want me to graph. All right, so this first function they're giving me, f of x equals 2x plus 2 over x. All right, so if you want to, I'll sort of hand draw what I'm doing here. All right, first the domain. Oh, the domain we're going to find, just like we did earlier, we're going to set x equal to 0. Guess what? We're done. Since there's only one variable down here without anything being added or subtracted, the only number I got to exclude from my domain is x. So that's going to look like this. Negative infinity up to 0. Then we union around 0 to kick it out. And then from 0, we're good to positive infinity. So we won't be able to put nothing on that y-axis there because that's where x is 0 at. And this thing's undefined on that. All right. Vertical asymptote I'll find next. So I'm just going to initial my vertical asymptote V over A, VA, okay? Well, y'all remember, to find the vertical asymptotes, I set the denominator equal to 0. Just like I did with the domain. These two you find exactly the same. So that means my vertical asymptote is going to be x equals 0. So my graph cannot cross over this imaginary vertical line. So y'all, that means I don't have a y-intercept, do I? How I cannot have a y-intercept if my graph does not cross over that y-axis, okay? And you'll see in a second why that happens. All right, what's next? X-intercept. X-intercept I found by setting the top equal to 0. And then I'm going to solve that for x. So I would subtract 2. I get 2x. That cancels. That's going to equal negative 2. And then divide both sides by 2. So y'all, this is giving me x equals negative 1. Now remember, the x-intercept has to be a point. So x is negative 1. The y would be 0 for the x-intercept. So y'all, let me make this go out a little bit now so we can plot that. So I'm going to go 5 that way. And I'll go negative 5 that way. So I know for sure it's crossing right here at negative 1 on the x-axis. All right, y'all, next is what my y-intercept. So the y-intercept was equal to f of 0. So y'all put a 0 in for these x's. You got 2 times 0 plus 2 over 0. We all guess what? We just put a 0 in our denominator. So this thing is undefined at 0. So since it's undefined at 0, that means there is no y-intercept. Well, we knew that because the y-axis is my vertical asymptote, basically, so I can't cross over that, okay? All right, y'all, so the only thing is to figure out how this graph is going to look. So let's see, where was my... Oh, we forgot one. We didn't do our horizontal asymptote. So it'll ask you for your horizontal asymptote before it does the x and y intercepts, okay? No, actually, this don't make you write them down. It just makes you put the domain, the x-intercept, and then the y-intercept. We're just doing this so we can figure out our graph, I guess. So the degree on top is 1 because there's not an exponent here. That's like a 1. The degree on the bottom is a 1. So y'all, these degrees match. So since the degrees match, the degree on top equals the degree on bottom. Since they match, my horizontal asymptote is going to be y equals 2. There's not a number in front of that x down there, so it's like a 1. So it's 2 over 1, which is 2. So that means my horizontal asymptote, when you put it in MATLAB, would be y equals 2. So y'all, let's find 2 would be... So let me go up on this one. 1, 2, 3, 4, 5. So right here at 2, as your x's head towards infinity, your graph is going to try to approach that 2. All right, so the only question is what to do with this graph. So remember, it's trying to approach this 2 up here. It's going to come down, cross over that x-axis at that point, and then it's going to shoot downhill. Now, this side will come in from the top because they're usually opposite than this one. It's going to come in up here, and it's going to curve, and it's going to try to reach that horizontal asymptote going to the right. So y'all, let me show you the graph on this on the calculator. All right, so we'll go to y equals, clear that. So y'all, once again, I'm going to make it look like a fraction. So alpha y equals enter. On top, I had a 2x plus 2. On bottom, I had an x. So y'all, all we're going to do is hit graph. And there's our picture. Now, it ain't going to show you those imaginary lines, but it's there, okay? All right, y'all. So a question on that. So I got one more we'll do. Okay, so this next one, we actually got to put in the asymptotes, okay, as the answer. But y'all, I'm going to show you how you get what we call a hole in the graph. So, check this out. if a vertical asymptote can cancel with the same factor on top, the vertical asymptote is canceled at that point, and it causes a hole in the graph. Now, MathLab in their answers, you'll be able to see the hole, but the calculator, it will not show you the actual hole on those graphs, okay? But those points, you will see that it's undefined, and that's why there's a hole there. So, y'all, this last example, this will be like y'all's number, let's see, 12, I think. No, this will be like number 13. They're giving us f of x equals x squared plus x minus 6 over x squared plus 5x plus 6. So this is an example where I would factor the top and the bottom. Okay? So we'll start out doing the bottom because we got to find our domain first. So to find a domain, we're going to set the bottom equal to 0. I'm going to solve this by factoring. So the x squared is an x and an x. Y'all, look here. This last number is positive. If the last number is positive, both of these factors will have the same sign as the middle number. So they're both going to be positive. All right, y'all, find me factors of 6 that'll add to get me a 5. So two numbers. Okay, Darren, you're pretty quick on those. So 3 and 2, good job. And y'all, it don't matter where you put them because they're both positive. Now, set both of these equal to 0. And we'll solve them by subtracting 3. I get negative 3. Subtracting 2. I get x is negative 2. So remember, my domain has to be in interval notation. So it's going to start at negative infinity. Now we're going left to right, so we're going to hit negative 3 before we hit negative 2. So we need the union around negative 3 first, then union around negative 2, and y'all, then from negative 2, we're good to go to positive infinity. All right, next, let's see. So next it wants the x and y intercepts. So remember, x-intercept, I set the top equal to 0. Okay, I'm going to solve that one by factoring. X squared is x and x. The last number's negative, so I'm going to have a positive and a negative. All right, now I need factors of 6 that subtract and give me 1. And that's going to be the same two numbers, right? 3 and 2 will give me 1 again. So the larger number is positive like the middle, smaller number is negative. And y'all set both them equal to 0. So I get a negative 3. and then I'm going to get a positive 2. But y'all check this out. This is saying I'm crossing the x-axis at these 2 points. Well, guess what? This thing is undefined at x equals 3. So since this is undefined at x equals 3, this asymptote is canceled out. I mean, this intercept is canceled out because this graph is undefined at that point. So my only x-intercept will be this one, and that'll be 2, 0. So y'all, you have to check on this stuff right here on these x-intercepts, okay? All right, next was my y-intercept. Well, my y-intercept, I found f of 0. So that'll be 0 squared plus 0 minus 6 over 0 squared plus 5 times 0 plus 6. Well, y'all, that's 0, that's 0. So 0 plus 0 minus 6 gives me a negative 6 on top. That's 0, that's 0. So 0 plus 0 plus 6 on bottom gives me a positive 6. And that gives me a negative 1. So that means my y-intercept is 0 for x, negative 1 for my y. All right, next I would find vertical asymptotes. Well, y'all, I find vertical asymptotes the same way I find my domain. I'm going to get x equals negative 3, x equals 2. But remember, since I got a factor in the numerator that matches this vertical asymptote, this vertical asymptote is going to be canceled and it's going to create a hole. So I'll have a hole in my graph at negative 3. But I will not have a vertical asymptote, okay? I'm just going to have a little hole at that point. So my only vertical asymptote will be the x equals negative 2. All right, y'all, the last thing I would check would be my horizontal asymptote. But y'all look here. The degree of the top equals the degree of the bottom. So that means my asymptote is y equals a over b. Well, y'all, a over b, there's no numbers there. So that would be like a 1x squared on top and a 1x squared on the bottom. If there's no numbers, we put a 1 there. And y'all, 1 over 1 equals 1. So my horizontal would be y equals 1. Okay, y'all, let me show you. I'm going to graph this on the calculator, then I'm going to show you their pictures. All right, so let me go to y equals and clear that. So alpha y equals enter for my fraction. On top, I had an x squared plus an x minus 6. On the bottom, I had an x squared plus 5x plus 6. So I'm just going to show you the graph real quick. So see over here at let's see, negative 1, negative 2. At negative 3 right here, you're not getting another asymptote. But right here at negative 3, there's technically going to be a hole right here. Now this side, My other asymptote was at -2. We are right here at -2. You can see that that would be like an imaginary vertical line that the graph is not crossing. And if you look out, it's trying to approach a 1 on both sides on the y, okay? So let me show you their pictures so that you can actually see the hole. And y'all, I'm going to zoom this in a little bit. Let me think. And then focus that. So y'all, here's what graph we had. And if you look right here, there is a hole at that -3. Your vertical asymptote that's left was at -2. And then there's the y=1 horizontal that the graph is trying to reach over time. Okay, so all of them are showing a hole, but we needed this one that looked like the graph we drew, okay? Really, y'all, so that's why we got calculators now, right? Because these are tricky graphs to draw. They're a little tricky, okay? All right, so I need to unzoom again and refocus. All right, y'all, so chat me up with any questions y'all got. Any questions over this? All right, y'all, so check this out. Monday, we're going to finish out test 3 material with section 8.6. It's a pretty easy section. And then we're going to start reviewing for test 3, okay? So test 3 will open next week and be due whatever that Sunday is. I can't remember. I think it's going to be due April the 12th. So what I'll do, um, you can do it on your own with Lockdown Browser, be due the 12th. Otherwise, if you need me to proctor you again like y'all did on the last test, we'll do that Monday during support time, okay? So I'll do my Monday lecture on the 13th, and if you're testing with me, then we'll start right after that and use our support lab for that, okay? All right, y'all. Also, in your email, in your announcements, I sent a test 3 bonus for you all to figure out. So look for that in your announcements, okay? All right, y'all. Anyone got any questions?